everything's online. So, hello fellow engineers. You forced me on the YouTube to make some tutorial videos. So I hope it will be enough in this case, because I don't have so much microphone for the computer. So that's all. Today we will start with first video. It will be about the theory with the trains, and some explanations to the wheel settings, and everything about creating the rails. And in the next videos later, I hope maybe in few days ago later, we can start building our rails. Building the rails is always the same, or at least similar, but it has its own rules. For all the trains there are their specific rules for building them, but only for me. It's not applied for all the engineers across the space engineers world, because some creators make trains differently. Someone plays it in survival, someone plays it in creative modes, someone can place the rails manually. Each part of the rail they place manually. It's full-time job, but in my case I go the simple and fast possible way, so we will see how to do it. So we are on my testing board. I've prepared first locomotive with the New Year design to the testing. It's not so okay, maybe we can show later or now. Okay, now. So I enter cockpit. This locomotive is specific for the wheel power, because there are no thrusters to power it, and automatic brake. And it's only powered by the wheels, 5x5 wheels. It's like a sum up system. It's very similar, but still a little bit different. There are no gyroscopes. Everything is how to say, buffed by the wheels, because they have friction and they make some difference on it. Also, our upper wheels are placed on the rotors, so they are like suspended, and it's a little bit better for something, but not sure if it's okay or not. So this is how it works. It works, seems nice. And maybe, of course, later I can show you the word settings, because also that's very important for it. So teleport back. So we can start. As I said, it has its own rules. For my railways, there are important settings to have unsupported stations, because you will always build with static grids. They have less impact on the sim speed, on the simulation. And of course, damage on, not on, off, damage disabled, because we don't want to destroy our train while building or testing it. We need to properly test it, and maybe later we can try it with allowed damage and see if it can survive or not. That's simple. Not our, but my builds are focused on several points. The first point is the visual effect, they must look nice. It's easy. Second point, they should reach some good speed. Yeah, for example, 80 or 100 meters per second, maybe more, maybe 200 meters per second. Yeah, but not every time the big speed or the large speed is great. Not every time. And because, for example, some app is limited to 100 meters per second because it can't reach high speeds in the turns, because it's deadly for it. So, something about theory. If we want to build some rails or railways, because usually we only don't want like this, which is testing a loop. Oh, it's not loop, okay? It ends here. We only need some rails, But if we want to build some railway with some story or some buildings around it, we need to know what we want to build. What is our goal? What we need to set our goals, the speed, how it looks, how it works, where it should be placed. We can create trains for space only. We can create trains for these Earth-like planets, where is very strong air, very high density air. And then we can build some trains for planets where is very strong gravity or where is no air, so you need to properly power it. And how you will power it? Several solutions. As I said, this train is powered by wheels. All speed is controlled only by wheels, the braking, increasing speed, parking, everything only by the wheels. The second solution, which is for me a little bit better, are the thrusters. Because for the thrusters we can use a script which allow us to keep the speed. It's cruise control script, and it will control all the thrusters. The second solution for this train is to place very weak thruster, and with the event controllers control the wheels. We will how to say, yes, we will check these thrusters for thrust, and if the thrust will be bigger than 5%, then we turn on the wheels and increase their power, and so on and so on. For the space, there are solutions like hydrogen thrusters and of course ion thrusters. Also, it depends how much power you need from it and how strong the acceleration you want. Of course, some people can say I'm working with mods. Yes, my older trains were built with mods, but these mods usually were like some blocks, trees or planets. Now usually these trains, my newest trains, are usually only vanilla with DLCs, so it's lots of different. And usually I use only mods for increasing maximal speed, planet, and for the building, like this. We can see on the left corner our informations about blocks. So some like these mods I sometimes use. So we can start. I will take my red color. The theory about wheels. Theory about wheels. Usually on our trains there will be two main groups of the wheels. Our main wheels, which will be red tonight, right? These wheels are responsible for holding train on the rail. They usually hold the whole weight of the train, and of course they are the main wheels. Yeah, later I will show different trains with different rails, and we will see which wheels are the main and which are the other wheels. Our second group, it can be, for example, blue, are the side wheels. Side wheels are responsible to keep our train on the rail. Yeah, with these wheels, our train can follow the railway and can turn. That's the simple. The third group, not everyone use it. Okay, we will make it green. Too much green. Green. These wheels. Okay, I mark it like this. These wheels are our support wheels. They have work like helping our train not to buck into the rails. And I think that's all. And some supporting wheels also help us to keep train on the rails, so it doesn't leave it in high speeds, because that's the main problem with lots of trains. They are limited to speed because, in the other hand, they will on the other side. I don't know. They will leave the rail because of strong centrifugal forces. Yeah, because centrifugal forces are our enemy number one, or maybe number two. Number one is weight. So this train is special. So it's not a good example, but I have prepared it. So these are our groups. 3 groups, and also there is 4th group, but it's special only for suspended trains. Suspended trains are usually only below the rail, not the above, but the below. And so these, for example, yellow wheels. They are usually small, and they are only helping us to take this train and put it on the rail, and then we can leave them. We can show it. I will find sum up, original sum up. It uses same technology as this one. Sum up number 2. Oh, I picked the whole train. I don't want a train. Oh, go. Maybe this one? Yes. Yes. Oh, that's the older model, but still okay. So here we are. Merge block. We can take it and leave it. So the train will be without these supporting wheels. They are only for our help to place the train. And again, we have supporting wheels, we have side wheels and main wheels. Usually main wheels, that's important. Main wheels, there are usually more the main wheels than the side wheels. But it's only for this train, because other trains, they need very strong side wheels. So I can place some realistic train. Locomotive. No, yes. Because I used mods earlier, so it will be without mods. It looks nice. Some older model. Maybe I can build for it some new rails. It will be fast, I promise. Maybe you will hear my keyboard because that microphone, I should buy the new one, but the good ones are expensive. So our realistic locomotive, to be sure, everyone knows it, these locomotives or these trains are the European trains, so they are really based on the real life trains. These locomotives are powered with thrusters. There are thrusters on the bottom. These locomotives does not use, or not locomotives but trains, they don't use any artificial mass, which are used previously, or heavy blocks. We want to make the train as light as possible. That's our goal. And here we have our wheels. Main wheels, the red ones. They hold the whole weight, and also they hold the train on the rails, of course. But when we apply centrifugal force, I can create some arrow, maybe. It will help to imagine. In the turns, depending on the speed, of course, on the turns, there is this centrifugal force. If we go very fast and on the very sharp turn, then this centrifugal force will be extremely high and it will derail our train. So we need something to block it, and that's why we have here these supporting wheels are green. These supporting wheels. And how these wheels work? It's simple. Usually these rails. Oh, I built it incorrectly. Okay, so the new. That's the correct way. And place these armor panels. So like this. Enter cockpit, and we can see it will be okay. We can see our supporting wheels in the action. They hold with these panels, and the train cannot escape from the rail. These panels are placed only in the turns. When we have only straight rails, we can use panels like this. We need to use panels on the straight rails too, because if we don't use them, there would be some kind of stair, or not the gap, but there will be the edge, and we don't want edges because they are a little bit clunky. And of course, we will go back to the wheels. We have side wheels. So main wheels, side wheels, supporting wheels. These buoys are also placed on the rotors. It has better behavior. It has much more smoother ride. So that's realistic train. Realistic train has also its own rails. Of course, I wanted these rails. And where is it? Where is it? Here we are. The next important point, if we are building rails, we need to turn off with our B the placing. This placing is not okay. This is okay. I don't know why, but it's making a mess. And this is how looks our realistic rails. We can place that locomotive again, and we have complete example for realistic trains. Next project, our maglev train. This is it. And how we place that maglev train? That's simple. We need to remove these upper parts of the rails, and we can place our locomotive C1. Why it's called maglev? It's simple. Because it looks like it's levitating above the rail. That's all. Nothing special. Will these work? Ah, they work. That's nice. I thought they are booked. So no. Back to the wheels again. We have side wheels, supporting wheels, and main wheels. Hey, there is missing wheel. Why is there a missing wheel? Or it's okay? I think it's correct. Yeah, it's correct because these have couplings in here. Below the train, there is coupling. It will connect these bogies together with the second train, with the wagon, because here we have hinge. Simple, extremely simple solution. In the middle there is control unit made with timer blocks and thrusters. Another type of the rails, yeah, to us very well known, B-rail. Simple too, but it has a very big problem. There are lots of subgrids. Not sure if I have B-rail. Locomotive, loco. No. Oh, never mind. But here we have our special T-shape. T-shape was the project which was not finished completely. It was working, but not so good, so it will be okay. And maybe not. But we can clearly see the wheels, of course. We have the main wheels, support wheels, and no. These are side wheels, and these are support wheels. It looks a little bit like a roller coaster. Warm. Okay. Next, our last type of the rails. Monorail. Wow, that's extremely long. It's longer than I thought. Yes, I know, mods. And now our computer will explode. I think there is a hole in our train. And there are missing some blocks. But still we can see our wheels. We have bunch of side wheels. We have main wheels. But there are no supporting wheels. Because our center of mass is somewhere here. So it's in the line of the rails. So it's okay, but not the best solution. It's kinda big. Oopsies. I remove it because we don't want to have hot computer if we don't need it. And we can start with the theory about rails, maybe. I will keep with the wheels. We finished the topic of the wheels. So, we have several wheels. Now, how to choose the wheels? If we want the wheels to rotate, like for the realistic trains, they will have some friction and they will have limited speed, because wheels on the very high speeds they will start vibrating, and vibrations are not our friend. Maybe I can test it here. I will choose a little bit different color. That's better. I will place some small wheels. By 3, and okay, I will place all of them. Cockpit. Battery, maybe 2. And our engineer. Now we can set our wheels. Maximum power, some strength, it doesn't matter, and unlimited speed. If we rotate these wheels, they will start vibrating like our 2x2 wheels. And that's not correct. 1x1 wheels looks okay, but they are not okay if they are under mass of the train. Its weight will break it. So our decision on this must be correct. Do we want really, or do we need really the friction on the wheels? Yes? No? We need friction only for 2 reasons. We want to rotate with them on the rails, so it will looks better, or we want to use them as a source of the movement of the power. If we don't use these wheels for the power or the rotation, then we can enter their settings. And now, usually for the trains we can turn off steering. If we don't use them for power, we can turn off propulsion, maybe air shock. Yeah, turn off. Steering is offline. power, it doesn't matter. Yeah. And strength. Strength is important. Height offset, it's important too. And friction. We can set friction somewhere between 30 to 50% if we want to move from them. But if they are just holding the train on the rails, helping, usually supporting wheels, side wheels, we will turn off friction. There must be zero. That's very, very important. Next, unlimited speed. I think it does not matter, but we can set it. Back to the strength. Strength is the second most important setting on the wheels. The main wheels will have strength somewhere between 40 to 70%. And how to choose it? If we have a very light train which will go usually slower, then we can choose for 40%. Yeah, because it will be smoother, better. Yeah, but if that train will be heavy, we should increase it to 50%, maybe 55%. If that train will reach extremely high speeds, like 80 meters per second and more, to, for example, 300 meters per second, then we need to switch it from 60 to 70. I don't recommend to set more than 70%, because more than 70% it's extremely strong, and for some trains it can be problematic, because they will start jumping on our rails and probably will derail or buck or destroy the whole train, and we don't want that. So 70 is our maximum. On the other side, less than the 40 is dangerous too, because it will be extremely weak. Yeah. The number of wheels doesn't matter. That's the important too. If we have four main wheels, and we can imagine, yeah, I will put there only 20% because I said it wrong. We have only 4 wheels, that's the minimum. I will set it to 60%, it's okay. But then you will create the new buggies or the new chassis and say, I don't have 4 wheels, I have 8 wheels. So I can decrease it to 30, maybe to 20%. But that's not correct. That's not how this works. And it's not like I have 20%, so it's same like 40%. No. I don't know exact setting for it, or how it is computed, maybe. But it's not linear. Yeah, it's not linear. So that's important. If we increase the number of the wheels, we can decrease the strength, but only with the 5, maybe 10% maximum. Yeah, not more. And height, that's the important too. We need to from the wheels we need to touch them the rail, but we don't want to go against each other. Yeah, like this train. Yeah, this train. If I enter it, our wheels can go against each other, and that's the problem. Yeah, if I change it on the other side, then there will be an extremely big hole, and that's not okay. If I put them on the another direction, I will move with the train. They will be in collision with the rail, with unnecessary collision. And sometimes these collisions are not the okay. Yeah? This applied almost for all the wheels. Yeah? We need to set the offset of the wheels exactly right to have very very small gap between wheel and rail, but not too big gap, or the train will not be stable. So that's important. You can set it quite easily. We can enter our spectator camera with F8, move here, and we can maybe see how our wheels will move. Yeah? That we can find the exact point where they stopped moving, and here we are. That's all. It's simple, but it's important. Oh my god, my mouth hurts. I've never talked so much before. So I hope this will be everything for the wheels. I just check my notes. Yes, that's almost all. We can go back for our wheels. How to choose the wheels if we want to use 1x1, 2x2, 3x3 or 5x5. Of course 5x5 are extremely big. They are extremely wide and I hate it for the trains. I need 5x5 wheels, but very thin, like one block and not almost 3 blocks. Yeah, that's not okay. So, back to the wheels. My favorite or all favorite wheels are usually 3x3. They are okay for almost everything. They are durable, they have enough big radius or diameter, so they will react to the rails with better behavior than the 1x1 or 2x2 wheels. Of course 5x5 wheels are the best for it, but they are, as I said, they are extremely big, and for some solutions they are not so good. And as I said about vibrations before, vibrations are set on the speed of the wheel, on the rotation speed. We can say rotation speed is safe for the 5x5 small grid wheels, like 100 meters per second, but its diameter is 5 times more bigger than 1x1 wheels, so safe speed for 1x1 wheels will be something around 20 meters per second, maybe 30 will be still okay, but more than 30 can be a little bit dangerous. For 2x2 wheels on our left side, the safe speed will be double than the 1x1, so it will be 40 meters per second will be safe. But maybe we can use 50 meters per second too. But this rule is applied only if we rotate with the wheels. If we turn off the friction and we will not rotate with them, then the speed is not limited. And that's extremely important. Then we can choose the smaller wheels as our supporting wheels or side wheels, because they will not rotate. And only main wheels will rotate. I can show again on that locomotive, on that green locomotive, that our main wheels will rotate on the touch with the rails. I hope you can see it. They rotate. But other wheels have no friction. The friction on the wheels on the trains are also our enemy. Maybe you can be asking why? Why is it our enemy? It's simple. Friction forces wheels always to go forward. So if we would, or not would, if we apply some friction for the main wheels, they will have a little bit problems with turns, because wheels want to go on a straight, but the rail goes on the left or on the right, and there is a little bit problem with it, because it will create force on our side wheels, because side wheels are forcing our train to go to left, as we see it on this soldier or engineer. Yeah, so our main wheels want to go straight, but are forced to go left. The same rule is applied for side wheels too. Yeah, side wheels are going straight, but in this case, it's not a problem to go up or down in their point of view, but they will have problem if the rail will go up or down. Then they will force the train to leave the rail if the rail will go down, but not but. Please. My brain does not work. Or if the rail will go up, it will go up. Maybe I have something with up. Ooh, I have up. But it's very small up. It will go up. Then the main wheels will have some strength against them, because side wheels are forced to go straight, or forcing our train go straight, but they are forced to move the second way. So that's why friction is our enemy on the wheels. The friction on the wheels will create another forces for other wheels, and that's all. It's not simple. I wanted to say it's simple, but it's not simple. You must to imagine how are these forces create or how they behave, and then that's all. It's only about the geometry and mathematics. So, theory about wheels, that's all. Now, the theory about rails. I already placed several rails, several group of rails. The monorail, T-monorail, simple monorail, B-rail, maglev realistic rail, and realistic rail. And now we have here the cable rail. For example, cable rail. I can build here some good wall. And we can create some profiles. Profiles of the rails are very important. They will tell us how the train will be held by the rails. I will choose the red one. So, the profile. I will take our f8 camera because it's better for the building. Yeah, please use f8 camera. It's better. It's faster. You don't move like with the jetpack. It's instant movement. It's better and faster. Of course, you can increase or decrease your movement with the Alt and wheel, or etc. with wheel the rotation or sensitivity. So we can start with our realistic rails. So we have sleeper and rails. That's all. The second generation, which is under us, there is like this one. Oh, I chose the wrong. Like this. Yeah, it can hold our train. We can some walls for the side wheels and for the main wheels. Then we can create something for monorail or more simple monorail for the minimalistic monorail, or maybe this one, or our cable rail. Yeah. Next can be T monorail, which can be like this one. Yeah, we can place the train above the rail as we placed before, and here we have some planes for our supporting wheels and walls for the side wheels. It's crazy, it's simple. Wheels for the B-rails, of course, like this, or this, or maybe something bigger. You can imagine there is a train between these rails. Next can be our maglev. That's the smaller type of this one, because it's almost similar profile. We will place the sides of the rails and upper place and bottom. Bottom are must have, upper are must have too, of course. And all these are currently used all in my project, but not these ones. But all these were used by me, all my in my older projects or in my new projects. I had an idea to decrease the number of the blocks to create the extreme small T-rail. It sounds weird, T-rail. And it looks like this. Now I can check the passage. Passage is the nice block for the rails. I saw several creators using these passages. They are used like this, usually. This is for our suspended train, where the train will be hanging below it, or for the normal train, where entire train will be above it. Yeah, this block between them is important too, because it will not join. No, it will connect our left side and right side together. It's important, but I will say it later. And how these passages works? We can place in a dam the 3x3 wheels. They are exactly in this gap. They are very okay. Okay, I can't place there the block, but the 3x3 wheels are the best for it. And then we can use 1x1 or 2x2 wheels on the sides, on these sides. So it's okay, because our main wheels are our supporting wheels at the same time. But of course we need usually more wheels. I have some project which used this design too. It's a dragon, blue dragonfly. We can see our fourth group of the wheels, and here we have our wheels. We have 5 wheels or 5 pairs of the wheels to keep it more stable, and they work as a main wheel and as a supporting wheel. And here we have only 1x1 small wheels as side wheels. It's simple solution and it's working quite nice. It's looking like a metro, and it's the old one. So that's all. I think lots of creators are using the blast doors. I really don't know why they use blast doors, because they have extremely similar behavior like classic armor blocks, like this. Yeah, well, of course we can use blast door like this or like this, but they have very similar to classic blocks, but they for survivor they need much more materials, so that's not why they are not good, I think. And also they have more triangles, but of course this will be later. So I hope I mentioned all the possible profiles which can be used for space engineers. Every time someone create, yeah, we have beam blocks. Of course. Developers made some extremely simple monorail on the beam blocks. I don't know how they hold it, but it's working. But I know it's working only for very slow speed, and they cannot properly turn, so it can go only straight and slow, but not slow. Okay, I think it can reach maybe 40 meters per second. Still okay. We have another option. We can have rails like this or like this or this. Yeah, still simple, still easy, but behavior for every of these types of the rails will be every time different. I saw someone building rails from the small grid blocks. That's not good idea for large railways because it spend a lot of CPUs and it's not stable because small grid is not or can't be station without mod. There is mod which can turn small grids to stations. Then okay, you can create small grid rails. I think it's all for this topic almost. What about materials? Maybe. Yes, maybe materials. We always try to build rails as we don't have materials. Less blocks per one distant block is better. That's the extremely simple rule. For example, these rails, tell me how many blocks they have per one distant block. Distant block, you can see from the side, distant block is this. So we can count all blocks, for example, on the distant like 20 blocks and divide it by the 10. So how many blocks are here? 6 blocks. 1, 2, 3, 4, 5, 6. 6 blocks. Here are 4 blocks, but there are also sleepers. So there will be something like 5.5 blocks per one distant block. I think 6 blocks per one distant block is should be our maximum. Our maximum here is also increased with these power lines, and they increase it extremely fast. So for these rails with power lines, there will be something like 7 or 8 blocks per one distant block. For this kind of the rails, there will be also 6 blocks, because we have middle block 2 times and side blocks, because we want to have it looking nice. Without these sides, it wouldn't be a cyber train or cyber rail. So here we have 6 blocks per one distant block again. Of course, we have some pillars, so it will be also increased. Here we have only 3 blocks per one distant block. That's great. We have pillars, okay, they are doubled, but still it will reach maybe 4.5 blocks per one distant block. Here we have also 3 pillars, but they are smaller, so it will be again 4 blocks per one distant block. And our cable rail, my newest project, have only one block per distant block. That's the best. I think it's the best. Of course, there will be some pillars, but they will still increase it only by half block per distant block, maybe. So still it's very low. There is only one solution how to decrease the number of blocks, and it's our newest block in this time, Okay, of course, now we are waiting for a survival update, but still, this is our newest block, and it's this one. I can place it somewhere here. It can be horizontally or vertically aligned. This is extreme because we have only 30% of block per one distant block. That's the crazy, yeah. It's extremely crazy. But it's very wide or very high, so still it's not okay. How to choose the block itself? Usually I propose to use the classic armor blocks or these armor panels, because they are simple and they have less triangles. Triangles are here. If we place something with the panel, we can find it in the information. Physical shapes and triangles. Higher numbers affect performance. That's the important information. If we want to build extremely long railway, we want to reduce this number of triangles and physical shapes. So the classic blocks are the best. They are the best because they have only few triangles and we can create larger rails, and still it will have less triangles than this round block. These round blocks are the worst, but somehow they are working. But they are worst. These ones, they have lots of triangles too. These ones, they have lots of triangles too, but they have another problem. If you place lots of beams at the same time, like this, it will spend more time and it can have problem with the shadows. We can try to move with our sun. It will try to generate extremely combined shadows, and it's not so okay. Oh, I made a huge mistake. Oopsies. Okay, never mind. I will not save that, I hope. So that's why I don't recommend these blocks, and I recommend to use the simple blocks. The berail system, it will be the last information for today. The berail system has another problem too. I don't know if I can find something with that. Maybe yes, maybe no. Probably no. These rails have problem with subgrids. When we are building turns, we usually remove all the supporting blocks and hinges and rotors, which are holding rails together, and they will disassemble to the simple grids. Yeah, here we have 1, 2, 3, 4, 5, 6, and maybe 1000 subgrids. No, not subgrids, grids. Static grids. But for these rails, it will not be 1000. It will be 2000 grids, because the upper and bottom rails are separated. So it will make the twice of the grids. and that's why that my older project crashed and I wasn't able to finish it. There is invisible limitation in the game which tell us we cannot use the more grids, and it's very problematic. And in my previous project I made a large grid burial system, and it used these blast door blocks and same problem or similar problem. I had problem with spawning anything because it crashed my game if I used blast doors. When I loaded all the save of that world where I haven't built that part of the rail, and I built it from simple blocks. So I had one half a railway with blast door and second half with standard blocks. It was a little bit problematic, but several settings and it was okay for the train. Then I was able to finish that railway with normal blocks. So I wasn't limited by the number of grids, I was limited with number of blocks. I counted like from the length, and that limitation was I think 100,000 blocks was the limit. So I was limited by this, and I think same problem could be with these rails. Normal armor blocks are okay, but these panels, I think they were problem. There were lots of side panels. It exceeded something about 150,000 blocks, and then game started crashing. So I recommend to use classic armor blocks, light armor blocks. It's better. And how to use or what pattern to use is only up to you and and on your graphic card, because some of these skins can affect performance much more than others. So I think that's all for today. I mentioned everything, every information about wheels and their settings. I show you something about rails, how to build them, how to choose them, and possible solutions, and what each rail has its own problems or not. In the next video, it will be part 2. We will start building our rail system. I'm not sure which one it should be now, but I think it will be something like CEMEP, so this one with the round blocks, and the second solution with the square blocks, because it will be a railway for space, maybe, probably. So that's all for today. I hope it was something new for you. I hope my English is okay, because I don't trust myself so much, and I hope I will buy new microphone, because it will be needed if this kind of videos will be wanted. If it will not be wanted, that's okay. I already made lots of videos, and I can't bring something new. So now I'm waiting for releasing Space Engineers 2, maybe vertical slice for free, where should be planets, and I hope there will be wheels too, so I can start creating trains. So have a nice day and good luck with your trains. Bye.